Gloo is a function gateway built on top of the popular open source project Envoy. The goal of Gloo is to decouple client-facing APIs from upstream APIs. Gloo is similar to an API gateway, which is a tool that software companies can use to collect all of their APIs in one place and impose security, monitoring, and other standards around those APIs. The goal of Gloo is to provide all the tools necessary to glue together traditional and cloud-native applications. Idit Levine is the CEO of Solo.io, a company that is building Gloo and several other projects. Idit was previously on the show to discuss microkernels, and it was great to have her back on the show. I hope you enjoyed this episode. Azure Container Service simplifies the deployment, management, and operations of Kubernetes. Eliminate the complicated planning and deployment of fully orchestrated, containerized applications with Kubernetes. You can quickly provision clusters to be up and running in no time, while simplifying your monitoring and cluster management through auto upgrades and a built-in operations console. Avoid being locked into any one vendor or resource. You can continue to work with the tools that you already know, such as Helm, and move applications to any Kubernetes deployment. Integrate with your choice of container registry, including Azure Container Registry. Also, quickly and efficiently scale to maximize your resource utilization without having to take your applications offline. Isolate your application from infrastructure failures and transparently scale the underlying infrastructure to meet growing demands, all while increasing the security, reliability, and availability of critical business workloads with Azure. To learn more about Azure Container Service and other Azure services, as well as receive a free ebook by Brendan Burns, go to aka.ms/sedaily. Brendan Burns is the creator of Kubernetes, and his ebook is about some of the distributed systems design lessons that he has learned building Kubernetes. That ebook is available at aka.ms/sedaily. Idit Levine, you are the founder and CEO of Solo.io. Welcome back to Software Engineering Daily.
Well, thank you so much for having me.
The last time that we spoke, you were at EMC, and since then you've started your own company, Solo.io. How has the transition been from working at a large organization to running your own company?
Yeah, so that's actually interesting. But actually, over my life, I work in a startup company. So actually, the transition to actually EMC was really strange because it was a big company. So I'm basically back home, right? Because all my life did startups. So yeah, I mean, I much like it because I feel that you can go much faster. There's not a lot of the overhead of a big organization. But then again, there is a lot of advantage to being EMC. For instance, much easier to get, coverage or people to listen to you because you're coming from big organizations. So there is a trade-off,
Was this the first time you started a company, or had you started a company before?
No, so that's the first time I started it. I worked in companies, but I never started. That was the first one. Right.
How's the experience of starting a company differ from being an early employee at a startup?
I mean, it's much harder specifically because I'm the only founder. You need to do all the work, so it's everything on you. So you need to raise the money, and you need to get investors, and you need to find a space to sit. And so there's a lot of work that you do need to do in the beginning to kind of like jumpstart it. So there is much more responsibility, right? You need to do a lot of stuff, but also you're responsible for this. If this is failed, this is on you. And as an employee, you do want that to succeed a lot, but you have less skin in the game. So
right. And when you started Solo, did you know what you wanted to build, or were you tinkering within a universe of ideas?
So actually, this market moves so fast. So when we started in the beginning, what my plan was, actually even before I got the money, what I pitched was regarding serverless. And actually I had this idea for like over a year. And it's moved, right? So when I kind of like came to a point that I actually got the money, I couldn't, I had to actually, twist it a little bit. Actually what we did, we actually extend the idea. So before it was only about serverless, and then I saw the movement, and I also looked and I figured out that this market is moving of the serverless, but not as fast as I wanted it to move. So I said, we need also to kind of like include the current situation of the market, which is also monolithic and microservices. So that's what we did. We basically took something, and that's how Gloo basically was born, right? Because basically in the beginning, Gloo was, well, we're probably going to do it only on the serverless. And then we say, you know what, actually, the biggest problem in the market right now is actually to move from monolithic to Microsoft to serverless. So what if we're just going to extend it to be able to do everything?
Right. So you can see where things are going. Eventually people are going to want to deploy applications in a serverless fashion where they're not addressing specific containers. They're just deploying their applications as collections of functions, and they can perhaps choose whichever cloud provider they want to deploy these functions onto. Maybe they do it based on price. Maybe they do it based on performance or some workload specificity. But we're not there today. We're significantly far from that future. In fact, this like you said, the space moves very, very fast. Not only does it move very fast, it's very hard to tell exactly where we are in the timeline. How far? Because serverless, people talk about it a lot, but as far as when I was at KubeCon recently, plenty of enterprises are eagerly pouring money into buying a Kubernetes provider or a collection of Kubernetes security or Kubernetes monitoring, and that's where the money is right now. But it's very clear that eventually the enterprises will move towards more serverless stuff, but it's just not there yet. So it sounds like you kind of wanted to hedge your bets a little bit and get into a market that today would have some customers.
Yeah, so exactly, right? As you said, right now I'm a startup, right? Which means that I actually also need customer. And when I was in EMC, that wasn't my case, right? I could actually do whatever crazy project that I want because my job wasn't to bring customer. We knew that, we will have customer. That's not a problem. So, here I need to have customer. And when you're looking at the market and you understand what is the pain point right now for customer, it's actually not in serverless, right? They are still struggling with moving what they have currently, which is monolithic, to microservices. And therefore, but I'm a big kind of like open source person. I really like innovation. I want to help define the future. So what I did is I said, and that's exactly where it's coming from, is, okay, so I want to help move customer to where we want to go, but I also want to, to play in the ecosystem of the open source because that's where I'm usually playing. So what I did is exactly how Gloo born. It's by basically I said, well, I'm going to fix the problem that people have right now, which is from monolithic to microservices. But I know that in the open source, there's people right now have microservices already, specifically, the Google of the world, but they might want it to kind of like also move to serverless and basically glue this environment. That's why Gloo, right? Basically glue this type of application together to one application. And that's basically the all use case. And that way I'm playing, I can get customer definitely because, I don't know any enterprise customer that doesn't suffer from this problem today, which the movement, but I also bringing something to the open source community, which is interesting and it's also a problem to solve.
Right. So if I think about your product, Gloo, or the thrust of your set of products, the idea is that let's say you are Procter & Gamble and you have all of these legacy applications internally, and you've also got perhaps some newer applications. Somebody within Procter & Gamble has spun up a Kubernetes cluster and it does new things, and it does new things that would ideally leverage the old things. Perhaps you've got an old inventory management service and you've got some API in front of it that you've built, but you need to be able to glue together that legacy API and your newer Kubernetes installation, for example. So you want to be able to glue those two things together. Or maybe you've done M&A and you've got three different companies you just acquired, and you want to glue those acquisitions to your existing applications. Are those some of the use cases that you're trying to appraise here?
So Gloo can do that as well. But what I think that is more important is the fact that a lot of the enterprise today that has a monolithic application, everything that they're doing new, which is, greenfield, they will do on Kubernetes, right? But the old things are still there. And usually what they're doing, they decided to rewrite them, right? Refactor them. That's the biggest problem today. Now, there is two ways to do that. The first way to do it is just said, well, we need to get to a point that we're rewriting all these monster monolithic application to a microservices. That's one option. But that's a lot of the time is just not successful because there is a lot of functionality. It's very, very complex. And more worry is that even if you do try to do that, you're not writing any new feature on this time, right? I mean, I had a customer, for instance, that, he had a monolithic application and they really wanted to move actually all the way to serverless. So they basically, went to their boss and said, look, we want to rewrite it. It will be so much better. We can run faster, right? Everything will be so much easier for us. So the boss said, tell us how much time it will take you. So they went and did the research. They came back. They said, well, it will take us 9 months. And the boss said, so no. And here is why. Because that means two things. A, is that probably it will not going to take you only 9 months. It probably will take a year or a year and a half. And the next problem is that on all this year, I didn't get even one feature, which means that I will get fired, right? It's like, you're innovating a new room, but you're only doing piping. In the end of the day, you can see that, right? So that's basically what we're trying to do. What we're basically telling our customers is we want you to extend the new functionality to the, of this application to microservices and serverless. And we will glue it like it's one application. And then in your spare time, because we're cutting all of, and I will explain in a second, but we're breaking your monolithic application to function, which is really small unit of compute, you can actually move them piece by piece gradually when you have time. And it's more than this. I mean, they need to learn new tools, right? I mean, if you're doing monolithic application, you will use something like Puppet, Chef, Ansible. You will have, Splunk for logs. And you will have probably SOA architecture. When you move into microservices, it's all a bunch of new tools, right? Because now it's distributed application. So you will use something like Prometheus, and we use something like open tracing. They need to learn. And basically what we give them is time. Because we tell them, first of all, you're already going to the right direction because we're basically adding serverless and microservices in the new features. But also, we're giving you the ability to gradually move it with no rush.
Okay, so the company is Solo.io. The main product is Gloo, Gloo. Explain what you have built with Gloo.
Okay, so first of all, I will start by saying that Gloo is a platform. And the point is that this is the base project. It's like Kubernetes in the terms of like, we needed it in order to build what we really want, right? And now we're going to come with a lot of small product that you will see in the market. So what is Gloo? So basically we are in the open source and Envoy is the best proxy. I mean, maybe let me start by explaining what we really want to do. Okay. So when I look at all this ecosystem, what was the most important to me is to find the smallest unit of compute and basically try to break all the rest of the application to this small of compute, and then I can mix and match it. So if you're looking at, today you have monolithic microservices and serverless, which is basically function. But if you think about it, the monolithic is also built from exposed API function. And actually, also the microservices is basically built from exposed API function. So if I'm actually managed to discover all of them in the monolithic, in the microservice, and in the serverless, all the function, now I can actually assemble application from these pieces. So what I need to do in order to do something like this, right? We need to, basically break the application, which is mean discover the function and be able to route to them. And that's what we're doing. We're doing that with two things. We have a discovery service that it's discover all your infrastructure in terms of, the regular upstream. So like Kubernetes and Cloud Foundry and everything we discover. And also, your AWS instances. And then the other thing that we're doing, we're discovering functions. So if it's serverless, it's easy. It's just the REST API. But if it's not, we're basically supporting Swagger. So Open API basically, and a gRPC. So if you're using one of those, we'll be able to basically get the specification of the functions. So now assuming that I took all your application and managed to break them not to break them, but discover the function in them. Now the only thing that I need is to basically be able to route to those functions. And that's where we use Envoy. So what does it mean route to a function? So Envoy is the best, for my opinion, proxy that exists there. It's worked very well with our use case. The only thing is that we wanted to extend it to route on the function level, because today every proxy that exists usually routes from route to a host or a service. So what we did, we basically used the filters of Envoy and extend the filter with a base filter to actually route on the function level. So now every feature that you can get today in Envoy on the regular level, I don't know, rate limiting, security, and so on, now transformation filter and so on, now you can actually get it on the function level. So I mentioned canary of function though, not services. So we did that, we extend that. Besides that, we wanted to extend, we wanted to make it very easy for the user. And we thought that if we will be on the request path, we would be able to manipulate the calls. So what we did, we basically put a lot of, created a lot of filter that relatively, it's basically working very well with functions. So for instance, a call for AWS with the signature already. Transformation filter to transfer from any language, from JSON, for instance, to gRPC to HTTP and so on. So we did all of this. So what we created is basically we took Envoy and extended its functionality to work with very well with functions and route on the function level. So that's the first thing that we did. But now it's Envoy, so we basically need to manage it. And what we build Gloo. And what Gloo is basically, it's a service that watching three things. The first thing that is watching is upstreams and function, basically the discovery that we're doing. The second thing that is watching is the secret. So we're supporting right now Kubernetes secret and Vault. And the last thing that we are watching is the configuration. So the user configuration. So we're using right now either YAML, CRDs, or console. And if one of those change, Gloo getting this information, but it doesn't understand anything. And the only thing that it's doing is basically saying it to a plugin. So basically all the logic of Gloo is in the plugin, which means that it's really extensible. So for us to add features, support something, the only thing we need to do is basically add a plugin and maybe a filter in Envoy. And we basically define our language. We can extend our language.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily. And thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show. From a technical point of view, I understand what you're building. I want to put it in the context of a large enterprise that is doing this cloud native or microservices migration. So they're doing containerization, they're building out CI/CD pipeline, they're instrumenting observability across their application. Where in this process would they start to use Gloo, and how would that help them?
So the first thing that they will do, they will install Gloo and it will discover all the environment. So no matter how much cluster there is, or which type of platform it is, or where it is, which cloud it is, they will discover all the application that's running. So now if we know all the application that is running, now they can start manage them. And what's good about Gloo is that you basically, that way, and I can show you a demo with it, is basically you can actually take a monolithic application, I don't know, pet store or something like that, written in Java, and start basically extending it by writing, I don't know, serverless or microservices, and then tell Gloo, now extend that. So we basically, if you think about, we are multiplexer, so we totally separate the client from the server, right? So basically can take this monolithic application and said, now I write an extension piece in microservices. So that way you basically can tell Gloo to extend the API. So now you basically have one application that is part of it is going to monolithic and part of it is going to microservices. And then the next step will be maybe to start rewrite. So this organization will go and say, well, I'm going to take this piece and I will rewrite it. And again, Gloo will be the one who basically make sure that it will basically, route it to a different place, to the new functionality. So that's that. Besides that, we also in the request path. And because we're on the request path, we can help you with other things. So for instance, if right now you're moving your application from monolithic to microservices, there will be a point that most of your functionality will be in monolithic, but some of them will be in microservices or serverless. So the big question right now is how you monitor it, right? Or are you using how that is going to work? You need to monitor, you need to get the logs, you need to, debug it. But now it's deployed and it's now in 3 separate places. So what we're doing is because we're on the request path, we basically has the ability, because we're invoking in every function, we can actually suck the information from the other platform and bring it into one place. So for instance, if you're running application that is a monolithic running on VMware infrastructure, then you have Kubernetes cluster and you're running there one microservices. And then you have also AWS Lambda that you're running. What we're going to do, we're basically going to suck the logs from all these places and suck the metrics and basically give it to one place. So it will be, I don't know, for instance, Prometheus, right? Or Datadog or anything else. So that's that. The same thing with open tracing. We're basically going to take all the information from the function and the monolithic and the microservice, fit it to open tracing. So now you can see actually a span that some of it is monolithic, some of them in microservice, and some of them is serverless, which I think really cool. And the last thing is that we also built Squash, which is basically debugger for distributed application, which you can actually attach debugger. I mean, we're doing it very, very nice user interface. From the IDE, you can attach the monolithic application reading in Java to a Java debugger. You can attach the microservice reading in Go to, again, Squash is doing it, to a DLV, and then Node.js to the function, and then you basically can debug it like it's a one monolithic application, even though you're jumping across workload, if it makes sense. It's much easier to show it than to talk about it.
Yeah, no, I believe you, and people can definitely check it out by going to solo.io. So can you help me understand how a company would integrate with Gloo? Like, where along the path do I spin it up, and how? So you said it can discover all of the services that I'm running. How does it do that? Like, how does it plug into my existing infrastructure?
So if, for instance, let's just take an example. Let's say that you have a VMware and you have a Kubernetes and you're also using AWS, just for the example. So we basically going to Kubernetes, ask for the upstream. That's easy. And then we're also looking at each of the upstream to see if you have any function that we can recognize. For instance, if you're running on this service in microservice, on Kubernetes, you're running, let's say, application with Swagger. So we collect that as well, right? So we're basically going to find all your workload cross clusters, and then besides that, also the function that's running on top of them, and also the regular application that's running on top of it. So now if we know that, we can act as a regular API gateway, because, by far the way we build it, I think that there's no question we are the best API gateway that exists today in the market. But also, we will give you a lot of tools to actually migrate those applications in case you want. So again, you decided that you want to take application A and you want to move it to somewhere else, to a microservices. That's where you will basically use Gloo. That's one option. The other option is that if you're looking at a lot of the offer today, like for instance, just for with Cloud Foundry, they're using Kubernetes and Cloud Foundry today. So they have like the container runtime and also the application runtime. there is nothing that make them work together besides Bosch who is deploying them. So we need something to glue that together. One place that people can actually see all the workload and, maybe create an application that some of them living in this cluster and the other one living in the other cluster. That's where Gloo can help as well, right? So if you think about it, there's so much offered today in the market. There is Docker, we're also giving Docker Swarm, and there is a DCOS, a Mesosphere that basically offering DCOS, but also Kubernetes. There is, Cloud Foundry, as we said. So there is a lot of kind of like platform that today when you're building them, they're basically giving you two different clusters that are totally silos. And I think where Gloo can help is basically glue them together as well.
You mentioned this term API gateway, and I think it's synonymous with function gateway. There are probably some people in the audience that don't really know what these are. Can you describe what the purpose of an API gateway is?
Yeah, so API gateway is not new, right? It was like, I think there was a lot of company that spin up before, like Apogee and so on. Basically, the API is the idea of instead of managing API of each server, right? So you have a lot of workload and each of them has an API. They basically abstract that and manage that in one place. And now you have a way to actually configure them on, for instance, security. Who can see what? And you can manage them and make sure that they are secure and so on. So this is the API gateway. What we're doing exactly the same thing. So we're allowing you to use it as a regular API gateway, which means that, a client come with a request, it should go through the API gateway and you can, route it to the right place. But we also can offer you that the same thing on the function level, which means that, first of all, you can go and call function from a serverless, which we were already signing and so on, and making the call for you. And also, you can go to a Swagger function and so on and get all the function, like, again, that API gateway usually giving you, like, for instance, first of all, it's giving you metrics and monitoring and tracing. That's something that usually they're giving out of the box. But they're also giving you, all of this, the regular functionality of the security that they're putting on top of it, the management itself, transformation sometime, and so on.
So the purpose of an API gateway is like, I'm a company and I've got 5 development teams. One is building the sales software and they've got their own servers and containers perhaps. And the other, then there's a marketing software team and they're building the marketing software and it's on maybe it's on Cloud Foundry. And both of these things, both of these teams are going to expose APIs, and the API gateway is the place where you can aggregate all of these different APIs and not really think about what backend infrastructures are running on. And the API gateway is a good place to standardize things like security practices.
Yeah, security management and orchestrated, right? That's basically the 3 things that you will want to manage by API gateway. But again, it's one place that the administrator said, I have, 5 team, a lot of application, but in the end of the day, I can see and manage all the API in one place and make sure that they're secure and so on. So this is what is API gateway. And what we're putting on top of it is the fact that we also basically, because we want them to move, to one of the big use cases that we wanted to apply is to the migration between monolithic and microservices. It was important to us to do everything what people doing on the serverless level, but on the function level, that way there is smallest pieces that they will need to migrate each time. And that's giving them, the ability to do it more gradually than actually rewrite their whole service, if it makes sense.
So does a typical company that would adopt Gloo, they already have an API gateway and you're trying to not necessarily give them another API gateway, you're trying to give them a function gateway, which is something that does not replace their API gateway?
So we can do both way. I mean, we can actually complement the API gateway that they have, the current one. But to be fair, I do believe that the Gloo is the best API gateway that exists there. So, I will recommend them to already take that as also the API gateway and get the both functionality. But again, we also can work side next to the legacy API gateways.
Right. So if I already have a legacy API gateway, to help illustrate what you can do, what would a function gateway, the Gloo function gateway, what would that be able to do to complement the existing API gateway?
So there is a few ways. One way is just we're going to sack the information from the regular API gateway and basically do a chaining of proxies, which is not the nicest way, but if you really, really want to use your old API gateway, that's one approach to do, which is basically a chain of proxies, which means that every time that request will come, it will go to the one API gateway, which is the legacy one, and will do the routing based on this, and then it will move to Gloo. We'll basically apply it more on the function level. That's one option. And the other option is just basically to totally dismiss the other one, which is basically just to sack the information that he has and basically take over.
And if I were to just replace my existing API gateway completely with Gloo, what are I think we touched on this a little bit earlier, but let's revisit it. What are the additional things that I will get out of the Gloo API gateway?
So again, I think that the difference between us or any API gateway is the use case that we are targeting. And all the things that we're doing in Gloo today is all about migration. Take a monolithic application, transfer it to a microservices, transfer it to a serverless, right? So basically that's where we're targeting. So a lot of the features that you will get will be on that level. I will give you an example. If we already basically taking all the infrastructure and kind of breaking it to function, we're not really, but basically, you can call it that way. So a lot of the stuff that's happening on the ecosystem of the function, like for instance, event-driven architecture, it's very popular in functions, right? We can bring it to the whole ecosystem because now everything is a function. Something like workflow that's very popular in the function level. Imagine that now you can actually chain functions, but it can also be that the function is part of a monolithic or microservices. Again, much easier to show, but yeah. So you will get a lot of that functionality on top of it. And besides that, you're going to get the ability to, as I said, to extend your application in functions and the ability to actually bring also. So for instance, for event, what we're doing, we actually created a filter for nuts, which means that basically we can that way create an event and bring it to all the other ecosystem. Like for instance, say, monolithic application or microservices can be driven by events now. So a lot of this functionality that none of the API gateway exists today. Besides that, as I said, most of the regular API gateway are not going to give you a discovery. That's not something that people are usually doing. And the other one that we're giving that others not giving is a lot of, so as I said, we can do a lot of transformation because we're doing it on the function level because we know what the function is, so we can actually transform. We're doing a lot of security, which that's everybody will give you.
Sorry, could you dive in deeper into that transformation? What do you mean by that term transformation?
So I mean that you can actually do request or response transformation. Let me give you an example. Today, when you're actually running a Lambda, usually what it's giving you back, it's a JSON. But if I want this response to actually show in a browser, I want to return an HTML, for instance, that's something that we will do for you. So basically you can say, I want to transform this JSON request to an HTML, and basically it will, again, we are on the request path, so we can do a lot of remediation that way. So that's an example. Let's say that you have a backend of gRPC. You wanted to change your backend to a gRPC, but you're still using the old client, which is not a gRPC. So what we basically can do is transform it between that. And that way you will not need to write a full new client in gRPC, if it makes sense. So that's kind of like a lot of the stuff. So imagine basically what the transformation is giving us, which I think is really strong, is the real way to decouple the client from the server. And today it's not like this, because I will give you an example. Let's say that I have a server, and in the service I have, the domain, and then I have the API pack. Basically, the way we work with most of the proxy, they will remove, the initial, domain and so on. But that means that on the backend of the service, you need to have this basically path. So if you add, just for heck of it, version 1, blah, 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 you need to have this path on the service. Not in our case, because we totally decouple it. So that's another example. So basically, we will decoupling all the client from the backend. That's giving you a lot of use cases for transforms again, transform JSON, SOAP to REST and so on.
And again, the API gateway works off of Envoy, which is a service proxy. We've done a show about Envoy if people want to check that out. Explain how the API gateway utilizes Envoy.
So basically, Envoy is our proxy, which means that we basically defining him on any request, what is the route that you need to go, and we're putting some filters on it. And basically, we can, we're getting the request, and we can do, we can route to the right place, but we can also do apply a lot of stuff on it. So, for instance, we can, as I said, for instance, in AWS, we're basically putting the signature because we know the secret. So we're basically putting the signature, so that way the user doesn't need to take care at all about, applying keys and so on. And we can do a lot of other stuff. So basically what we're doing is we're writing filter. This is the way to work with Envoy. And you can put a lot of functionality, and functionality that will imply on the request path, on the response actually as well. So that's what we did. So this is basically the proxy, but now you need to manage the proxy. You need to tell him where to route, how to route, and that's what basically Gloo doing, or the API gateway. It's basically is giving a configuration to Envoy to know what to do basically. It makes sense. And also, because it's Envoy, so Envoy already have filter like statsd and open tracing and so on that we can actually leverage for metrics and so on. So again, we will configure that. What Gloo will do is we'll configure it, but in the end of the day, Envoy itself is the one that will get the request and act on it.
And how does Gloo compare to the service mesh model like Istio?
Okay, so Istio is a service mesh. That means that on every microservices that running in your on your infrastructure, on your Kubernetes, you're also putting next to it a sidecar with a proxy. And then you also trick this sidecar to always talk only to this Envoy, which means that way all the traffic in and out to this service is going through Envoy. So now you can manipulate that, right? So now imagine that you have actually this all over the cluster. Now you basically can create mesh because all those Envoy sidecar capable of talking between themselves. That's what service mesh is doing. What Gloo right now is basically using as an ingress. By using an ingress, is doing some stuff that maybe you don't need to do in a mesh. That's number one. Number two, is not deployed as a mesh. We mean that when we are routing for Envoy, there is one Envoy that routes you to the service itself, to the microservices. So, but to be fair, we are in Gloo, we can actually also do service mesh. We just know, it is a service mesh. We're just not using it as one. So basically we can give a multi-configuration to different envoys. So for instance, we can be a service mesh. We just, there's already Istio, so there's no point.
Can we take another top-down example? Can you explain how a larger organization would start to use Gloo, or maybe if you have an example of somebody who has adopted it or is experimenting with it, how they have integrated Gloo and how they've made use of it?
Yes, as I said, a good example is a customer that basically wanted to move from monolithic. As I said, this is the target that we are basically targeting. So, that would be our customer. So they basically wanted to move from monolithic to microservices. They actually decided to use Gloo as the API gateway. So that was kind of like easy for us. Basically put Gloo, we discover all the environment. They wanted to move they were on AWS, and what they wanted to do is to migrate their monolithic application to Kubernetes. What we did is we basically ran in Kubernetes, discover also the instances of the AWS. And what we did, we basically managed them both. So all the API, all the immigration and so on. And then we basically let them extend new functionality on Kubernetes. When they wanted, they would be able to, rewrite the pieces and basically move them to a microservices. And all of this being managed by Gloo in the terms of like that you can apply, you're basically changing the route and it's working. And Envoy is so good that it's like we're using the ADS API, V2 API. So it's so fast, it's so efficient. So you can easily change don't go to these microservices, those monolithic, just go to these microservices. So that's an example of basically nicely migrated application from monolithic to microservice. And if you think about it, this is the reason that Envoy was built, right? It was before every company that did a real migration like this, from Twitter to Lyft, basically they were using proxies. And I think that the reason Lyft was actually building Envoy, or Matt Klein built Envoy, is because of exactly this. They wanted to move from monolithic to microservices. So today everybody's talking in Envoy as two use case, usually using it in service mesh context, which is visibility, observability, and security. But I think that they are missing the fact that the first purpose of actually building it was migration. And that's where we kind of like leverage it.
Every team has its own software, and every team has specific questions about that internal software. Stack Overflow for Teams is a private, secure home for your team's questions and answers. No more digging through stale wikis and lost emails. Give your team back the time it needs to build better products. Your engineering team already knows and loves Stack Overflow. They don't need another tool that they won't use. Get everything that 50 million people already love about Stack Overflow in a private, secure environment with Stack Overflow for Teams. Try it today with your first 14 days free. Go to s.tk/daily. Stack Overflow for Teams gives your team the answers they need to be productive, with the same interface that Stack Overflow users are familiar with. Go to s.tk/daily to try it today with your first 14 days free. Thank you, Stack Overflow for Teams. Right, okay, I think I understand it now. So Envoy is a service proxy, and you use Envoy, you instrument all of your different services with an Envoy agent. And what Envoy allows you to do is things like changing your routing on the fly, or doing circuit breaking, or being able to, I think with Envoy you can do things like routing, a percentage of your traffic from, 30% of your traffic to the new service, so that you can, if you're rolling out a new instance of a service, then you want to route, 10% of your traffic to it to make sure it's stable before you route 100% of your traffic to that new service. And so you've got all of your containers or your servers instrumented with Envoy, and what you're saying is that Gloo is useful for a migration because you want to maintain all of your APIs from your API gateway. You want to have all of those have constant uptime, while under the hood Envoy is changing the percentage of routing traffic. And if you're wanting to migrate from your monolithic application to breaking that up into microservices, then you're going to want to do this gradual, percentages of traffic changes in order to test it over time and gradually move it to larger and larger percentages to the whatever medium you're migrating to. So if you're migrating from a monolith to microservices, or you're migrating from an on-prem system to the cloud, or doing hybrid stuff where you want to route, when you have a bursty workload, maybe you route the burstiness to the cloud, for example. Am I understanding things correctly?
So, that's one of the use cases, but you will get from Envoy a lot of others like retry, circuit breaking, rate limiting, traffic shifting, blue-green deployment, canary deployment, right? All of this you will get. But we also even doing that more because we want also the ability to actually change the route, right? But again, on the function level, to the right, when you actually migrating. So right now, if we're taking it and we're saying we have a monolithic application, there is 10 API for it, okay, just for heck of it. And I wanted only to change the functionality of one of them, and we will be the one that will say, every time that someone bring me a request, I will go to the monolithic application, but this function, that when I will get this request, I will go to the microservices. So basically, you have one application that some of it is the monolithic, some of it is the microservices, and so on. And that's giving you, just game you time to actually, instead of taking and do a blowout kind of like rewrite of all the monolithic, you can actually cut it to an API calls, if it makes sense, and take part of the application. And that's, as I said, this is the migration that's being done everywhere in Lyft and in Twitter and so on.
Can you describe that a little bit more? I think I'm a little bit confused. Okay. I didn't understand your last point.
Okay. So let's say that right now I have a Java monolithic application. Okay. It's exposed 10 function. Okay. 10 function that you can call. I don't know. Let's make it easier. Let's say that I have a calculator application and it's doing, plus, minus, multiply and divided. And so I have 4 functions that actually expose on the monolithic application. So now let's say that I wanted to migrate this application. One way to do that is just to go and rewrite all of this as a microservices. Okay, now this is a simple example, but theoretically, let's assume that it's, I need to create 5 microservices for it, or 4 functions. Let's go, because it will be easier in the serverless. Okay, so that will take me time, right? Usually it's not that simple application, which means that we need to rewrite all these applications. It will take me time. That's what people are doing today. They're trying to take this monolithic application and rewrite all in either function or serverless. What Envoy letting you do is basically said, okay, let's continue route. Every time that someone doing plus, minus, or multiply, I'm still routing to the monolithic application. But then I will take the divide function, and only I'm going to rewrite it and put it as function, like a serverless function. Okay? So what will happen right now is this. I have this monolithic application. It's still theoretically exposed. There's still 4 functions in it, right? But only when someone will call plus, minus, and multiply, it will go to the monolithic. And when the client right now will call divide, it will go to the function. You're basically running one application. To the user, it's look the same thing, right? You see calc/something, right? I mean, it's totally look to him like a regular client. But on the back end, what's happening is that 3 of the function will be called in the monolithic application, and 1 of them will be called on the serverless function.
Right.
So now basically, okay, now for this, now you have this application, which is totally separate, right? It's different type and so on. You still want to retry. You still need to do circuit breaking. You still want to make sure that the rate limiting is working. You still need to do the traffic shifting, blue, green, canary. All of this you still want to be applied. So it will. But now it will do it all, like, even though that your application is, spread it around, it will basically, Envoy will take care of all of this. I hope it makes sense.
No,
it's much easier to show demo. And then,
Yeah. No, understood. So I want to talk about the broader Kubernetes ecosystem, because you have an idea for how things are going to go from the current popular model of migrating towards Kubernetes to more people adopting serverless and using that more aggressively. And I think one point of debate that's going on right now is the whole idea around, should there be a standard around what an event is? Because many of these serverless functions get triggered on events. The way that people want to implement a serverless function is an event happens, you upload an image to S3, and that event triggers a function call, a serverless function call. And one of the things that people want, so some people want, is an open specification around those kinds of events. So for example, if I upload an image to S3, S3 would create an event that would be less S3 specific, so that if I wanted to instead use Google Blob Store or whatever it's called, or if I wanted to use Ceph, or I think Ceph is an object store, then maybe I could have cloud events that would be emitted from that object storage that would be not S3 specific. So explain why that's important. Why is the cloud events specification important?
So if you will actually have a language or the protocol to the standardization of those events, now basically what you can do is to basically treat all those cloud like one big virtual cloud, okay? So all the services. And basically you can orchestrate through them like a multi-cloud solution. So for instance, imagine that I wanted to actually order an Uber, okay? So I'm clicking on this button. That will actually go to my infrastructure on-prem, do some stuff, okay? Look that my visa is good. Then go to a different cloud, like for instance, AWS, because that's where my storage is. So I want to get some information. Then take this information and actually go to Google and use some other services that Google is supplying, because maybe it's better than what AWS is supplying. And then, go to Azure and do something else. So this ability to actually leveraging all the services in all the cloud will be much easier if there will be one language that all those services we're going to work. And then you imagine that you will have one big cloud and you can basically mix and match services. Okay, so, take the best service that is work for you. And that's also will mean, in a way, that you're not really locking to the cloud. So let's say that all your data is in AWS, S3. It means that the only thing that I actually need to run there is one small function only when I need the data. I don't need to run my instance there, for instance. So that will give you the ability to actually not be locked to provider. Now, the problem with that is that the question if the provider is okay with that. But that's a different question, right? Because most of this movement, it's actually been done for people who has a fast offer that is basically, kind of like like project like, the guys from serverless or the guys from OpenFast or Fission or Project FN and so on. Those people usually can run on-prem. Of course, we would love that will happen. I'm just not sure if this is something that the cloud provider themselves will be a big fan.
Right. This is the same question I'm unsure of. Would AWS Lambda specifically, would they be wanting to be open to this cloud event specification? And all due credit to AWS Lambda, they invented functions as a service. They were the first ones to
it, right? The quick question is why should they, right? I mean, if someone is on production today, serverless, most likely they're running on AWS. So for this specification basically means that people will not have to, right? They will be able to run on Google function, but use the, I don't know why they should, because they're owning this market anyway. But this is politics, right? It's not related to technology. I mean, this is a good question. From what I see, I'm not from what I see from far, I think that, it makes sense that Google will do that, maybe Azure, because as I said, they are not owning this market. But I didn't see that AWS is very cooperative on this. And maybe I'm wrong. Again, I don't have all the data, but that's what I see from far.
Yeah. Yeah, we'll see.
But I think what's cool about it is that basically the vision is right. The vision, I'm totally supportive of it. And as I said, when we built Gloo, that's where we start. When I pitch it to my investor, this is where we started. It's basically the ability to take all the cloud, create one virtual cloud that you can run workflow between them, that you can mix and match and so on. The problem is that the way I see that is that the future will be so far. It will maybe happen, but it will take a long time. So it's really cool, but I think that it will take a long time. That's why I extended it and said, you know what? Maybe that's also what Gloo doing. Gloo is as I said, because we build it as an event gateway. We build it as the ability to get events and route to different providers. So you can do that as well with Gloo, but I will argue that will be probably more popular in the open source community than actually in enterprise running this one. I have a customer and he said to me, we are totally ready for a lot of cloud, but not the multi-cloud part, which is basically going between.
So what's the go-to-market strategy? There's when I was at KubeCon recently, there were lots of enterprises that were looking to spend money. And there were also lots of vendors that were pitching to the enterprises. So you do have this two-sided marketplace where people are ready to buy and people are ready to sell. What's your specific strategy?
Specifically for me, we open source the platform because that's what we believe, which is Gloo. We're building stuff on it. You will see a lot of stuff coming from us soon that are basically more specific offers. So for instance, we just talk about 2 use cases of Gloo, right? One of them is the hybrid app, which is I call it hybrid app. It's the ability to basically glue application from different workload. And the other one is, for instance, Event Gateway, which is the ability to only do this in serverless and basically be able to get an event cross-cloud and so on. That's a different offer, for my opinion, for different people. I don't think that enterprise will care about Event Gateway in that stage. So that's what we're going to do. We're basically going to wrap. And of course, we're going to put a lot of magic on top of this that we're not going to open source. But basically, hybrid app is a one solution. It will be one offer for the customers. Event Gateway most likely will open source it because I don't believe that it's now, no one will pay for that. And there is a lot of more that we're going to bring soon. But again, I stay tuned.
Okay.
It's going to be very cool. I think that, we'll be in less than a month, we will open source something that, for my opinion, will be huge. But we will see. I don't know.
Okay. Well, I'm excited to see it. Yeah. Idit Levine, thanks for coming on Software Engineering Daily.
Awesome. Thank you so much.
If you are building a product for software engineers or you are hiring software engineers, Software Engineering Daily is accepting sponsorships for 2018. Send me an email, jeff@softwareengineeringdaily.com if you're interested. With 23,000 people listening Monday through Friday and the content being fairly selective for a technical listener, Software Engineering Daily is a great way to reach top engineers. And I know that the listeners of Software Engineering Daily are great engineers because I talk to them all the time. I hear from CTOs, CEOs, directors of engineering who listen to the show regularly. I also hear about many newer, hungry software engineers who are looking to level up quickly and prove themselves. And to find out more about sponsoring the show, you can send me an email or tell your marketing director to send me an email, jeff@softwareengineeringdaily.com. And if you're a listener to the show, thank you so much for supporting it through your audienceship. That is quite enough, but if you're interested in taking your support of the show to the next level, then look at sponsoring the show through your company. So send me an email, jeff@softwareengineeringdaily.com. Thank you.
Wow.